Hello students! In our previous video, we ended by saying that different hydrocarbon compounds are produced by different oxidation reactions. We learned that the product so formed depends on choice of the oxidizing agent and the type of hydrocarbon compound which is undergoing oxidation reaction. We learned that carbon compounds with alcohols as functional groups on oxidation give various products like aldehydes, ketones, or carboxylic compounds. But the question is, how is this possible? Well, it is all because of the different alcohol compounds and different oxidizing agents that we use. Let us understand this by seeing various chemical reactions. Consider one of the simplest alcohols, ethanol. When ethanol is reacted with alkaline potassium permanganate or KMnO4 or acidic potassium dichromate, that is K2Cr2O7, it gets oxidized and forms ethanoic acid. Now wait, did I just say alkaline KMnO4 and acidic K2Cr2O7? Yes, I did. So what do we do here is mix KMnO4 with a base like sodium hydroxide to make it basic or alkaline solution. Similarly, we mix potassium dichromate, that is K2Cr2O7, with an acid like sulfuric acid to make it acidic, and thus we call them acidic. Okay, now coming back to our reactions. What is happening here is that oxygen from these oxidizing agents is getting added to the alcohol group like this. So we get a carboxylic acid functional group. So is this oxidation? Of course yes. As we know, the addition of oxygen is an oxidation reaction. And to confirm this, just count the number of oxygen atoms on both the sides. Ethanoic acid, a carboxylic acid compound, has 2 oxygen, whereas ethanol in the reagent side, an alcohol compound, has 1 oxygen. These oxidizing agents like KMnO4 and K2Cr2O7 bring about these changes, that is, they cause the oxidation of ethanol. Let's look at another example. This time consider the compound 1-propanol, also known as primary alcohol. Now you will ask me what this primary alcohol means. Does it mean that there are secondary and tertiary alcohol as well? I would answer yes. Let me explain this to you. Look at these structures. In the first one, we see that the carbon atom is attached to only one other carbon atom in the chain. So it is called primary carbon, represented like this. In the secondary structure, this carbon atom is attached to 2 other carbon atoms on either side like this. It is called secondary carbon atom and represented as this. In third structure, the carbon atom is attached to 3 other carbon atoms, 2 on either side like this in the chain, and this one carbon is of the branch that is present in the parent chain. It is called tertiary carbon, represented like this. And in the last structure, the central carbon is attached to 4 other carbon atoms. Observe, these 2 are from the chain and these 2 are of the branches that are present on the same carbon on upper and lower side in the chain. Now if the alcohol group is attached to the primary carbon, then it is called primary alcohol. Similarly, if it is attached to secondary carbon, it will be secondary alcohol. This is what we mean when we say that 1-propanol is primary alcohol. We mean that here the alcohol functional group is attached to the primary carbon. So coming back to our reaction of 1-propanol. When it reacts with alkaline potassium permanganate or acidic potassium dichromate, it gets oxidized and forms propionic acid, also known as propanoic acid. So do we always get carboxylic acids from oxidation of alcohols? We have already seen that we get different compounds when we take different alcohols. So this time, let us take 2-butanol. And what kind of alcohol it is? Whether primary or secondary, can you tell me? Pause the video and think about it. Correct, it is a secondary alcohol. Observe that in 2-butanol, alcohol functional group is attached to the second carbon in the chain, and this second carbon is attached to 2 other carbons on its either side, and thus it is a secondary carbon, and this makes 2-butanol the secondary alcohol. Okay, so 2-butanol, that is secondary alcohol, undergoes oxidation in presence of chromic acid to form butanone. Yes, chromic acid is one other oxidizing agent. Observe the product formed here. Is it carboxylic acid? No, it is a ketone compound. But wait, did you notice the number of oxygen atoms on both sides? We find that they are same, isn't it? Both 2-butanol and butanone have one oxygen atom. Then how can we call it an oxidation reaction with chromic acid as an oxidizing agent? There is no addition of oxygen here, isn't it? But wait, look at this reaction carefully. During this reaction, indeed, no oxygen is added, but 2 molecules of hydrogen are removed. And as we know, the removal of hydrogen is also an oxidation reaction. Accordingly, this reaction is said to be an oxidation, although no oxygen is added. And from this oxidation reaction of alcohol, we get another class of compound, keto compound, butanone. Let's see one more reaction. This time we add another oxidizing agent. When 1-propanol is oxidized with oxidizing agent pyridinium chlorochromate, that is PCC, the product is not a ketone as we expect it to be. In fact, the product is aldehyde, that is propanol. Thus, we know that oxidation of primary alcohols results in compounds of carboxylic acid and aldehydes, while oxidation of secondary alcohol compounds results in the formation of cationic compounds. Also, using different oxidizing agents, we can get different products. With the oxidation of alcohols using KMnO4 or K2Cr2O7, we get carboxylic acids, while with PCC, we get aldehydes. Thus, what we have seen is oxidation of hydrocarbon compounds. In the next video, we will see one more interesting reaction, the addition reaction.